We think the moon orbits the Earth, we say that, but it's not what actually happens. Earth and the moon orbit a common center of gravity. So the moon does the heavy lifting out there, of course, but Earth does this in response to the moon. So really, the center of the Earth does not follow an ellipse. The center of the Earth does loop-de-loops around the sun, and it comes right on back. And so there you have your orbit. It's not even that. You know what happens? By the time it comes around, it is not in exactly the same place it was when it left off a year ago. There's a mismatch. The entire system with every loop is turning around the sun. We call that precession. All of these are happening simultaneously, and that's Earth's orbit around the sun.
Why exactly does time slow down your black hole? What's the reason? People never explain exactly why. They just tell you, yeah, time slows down. But why? It all hinges upon the fact that the speed of light is invariant. It doesn't change. Let's take a look at this light beam here that's traveling around the Earth. The Earth is a gravitational field, so it causes the light to curve or bend around it. If you notice, the lower side of the beam is moving at a shorter distance than the upper side of the beam. However, the beam is still reaching the end at the same time. But how does that make sense? Shouldn't the longer side of the beam be traveling faster to keep up with the shorter side of the beam so they end up at the endpoint at the same time? It's got to be that the longer beam is traveling faster, right? No. The speed of light is constant. So if the speed isn't changing here between these two sides of the beam, what has to give? Well, speed is distance over time. Speed's the same, distance is shorter, so time has to give. Time itself must tick slower for the lower side of the beam such that it reaches the endpoint at the same time as the longer side of the beam. So it's not the light beam that's changing, it's time itself that's changing. It's slowing down for the lower side of the beam. Okay, makes sense? Alright, let's move on. Now let's imagine a flat space-time diagram. There's no curvature, so space-time is flat. And remember, space and time are interwoven together. So here in this example, the x-axis is space and the y-axis is time. Now everything in the universe is actually moving through space and time, okay? In fact, everything in the universe is moving at a constant speed, the speed of light. So me, right now, I'm sitting on a chair, I'm at rest, I'm not moving through space, but I'm still moving through time, a heck of a whole lot, the speed of light. I am actually moving at the speed of light right now through time. Okay, so in this example, you have an object that's just at rest. Remember, even at rest, the object is still moving through time. Okay, so that's what this line means. It's moving through time, even though it's at rest, not moving through space. Now let's introduce another object which